Okay, team. Nothing new in this lesson. We're putting everything we have so far together. So we are finding in this problem intervals on which f is both increasing and concave up. Okay. And I've brought along our facts from the last lesson. So everything we need to know in this lesson is here. So f is increasing means f prime is positive. Concave up means f double prime is positive. Okay, so that's what we're trying to figure out, is intervals on which both these things are true. Now, I think many of you could figure this out on your own. Our move is going to be essentially to do what we were doing in previous lessons and what we were doing in the last lesson. So I'm going to take my derivative of my function, f prime. Okay, so there's my derivative. I'm going to go ahead and set it equal to 0 now. So I'm going to do these in this particular order. I'm going to take my first derivative, find the critical points, and find the increasing intervals, and then I'm going to take my second derivative after that. You can feel free to do both derivatives first if that's what you prefer to do. It doesn't really matter. Let's see. I can factor in 8x out of all of this, I think. So 8x leaves me x squared plus 6x plus 9, and then 8x, and then I get x plus 3 times x plus 3, right? I'm going to write that as x plus 3 squared equal to 0. I'm going to draw my sign chart, and -3 is one of my zeros, and 0 is one of my zeros, right? So -3 and 0. I'm going to plug a value in from each region. So -4, if I plug that in. Remember, this factor is always going to be positive. So I'm going to get a positive times a negative is a negative. Say -1. I'll plug that in here. I'm going to get a negative times a positive, which is a negative. And then over here, we'll plug in a positive 1. I'm going to get a positive times a positive, which is a positive. Okay. So remember, we want increasing intervals. So my second derivative, or my derivative rather, is positive. We'll say on 0 to infinity is what I conclude here, right? So there's my increasing region of the function from 0 to infinity. Now let's look into concavity. So I'm going to take my derivative of my derivative. So I'll get f double prime of x is equal to 24 x squared plus, let's see, 2 times 48 is 96 x, and then plus 72. And then I can factor out a 24 here. What would this give me? 4 times 24 is 96. And then 3. I'm going to set that equal to 0. And factor one more time. So I get x plus 1 times x plus 3. That gives me following zeros, right? And I'm going to draw my sign chart. Okay, so notice not every value on my sign chart from my first derivative shows up in my second derivative. So we're going to have to do a little bit of reasoning here once we've finished this to figure out the reasons where they overlap. So -1. And let's see, I'm going to plug in like -5 for this region over here, and I'm going to get a negative times a negative times a positive, so a positive on this region. Then in between, I'll plug in -2. I'm going to get a negative times a positive times a positive, so I'm going to get negative here in this region. And then over here, so bigger than 1, I'll plug in 0. I get positive, positive, positive. So positive here. Okay? So what we're looking for is concave up, right? So f double prime bigger than 0. So f double prime is bigger than 0 on negative infinity to negative 3 and negative 1 to infinity. Okay. Now you got to start reasoning about what's included in both statements here. Okay. So we have our regions where my second derivative is positive. We want to see where they overlap. Okay. Well, right away, I know I can eliminate that first region, right? So the negative part, because that doesn't correspond with my first criteria here, right? So this says bigger than 0, and these are all smaller than 0, right? So what we really want to do is just look at these two intervals together. Okay. And notice my top interval contains everything from my bottom interval besides that negative 1. Okay. So the conclusion that I'm going to draw is I'm going to get rid of the negative 1 from that interval and just say f is increasing and concave up on 0 to infinity. Okay, it's going to be my final answer. Because that's the only interval where both my second derivative and my first derivative are positive. We're going to do one more, but make sure you follow that. Especially, I think the hardest part is thinking about where the intervals overlap. Yeah, so make sure you understand it before you move on. And we'll do one more here. So in this example, we're looking for intervals where the function is decreasing and concave up. So that means we want f prime to be negative and f double prime to be positive. Derivative is going to be pretty quick, so we're going to get f prime of x is 3x squared plus 36x. And I can set that equal to 0. I can factor out a 3x. So I get x plus 12 times 3x. And then my solutions here are going to be x equals 0 and negative 12. Okay, and then so negative 12, 0. Over here, I'm going to get negative times a negative, which is positive. Negative 12 to 0, I'm going to get, let's see, we'll pick a number for that one, negative 5. So negative times a positive is a negative. And then over here, I'll pick 1 for this interval. 3 times 1, 1 plus 12, both positive, right? Okay. So we want an interval where f is decreasing. So that's going to be here, right? From negative 12 to 0 is our decreasing interval. So I'll say f decreasing on negative 12 to 0. Okay. Now it's time to examine our second derivative. Again, this is a nice quick derivative, so I get 6x plus 36. And you could actually factor that, or I could just set it equal to 0. What you get, right, is negative 6 is the solution to that. Okay. Then I'm going to draw my sign chart. My sign chart is quite easy in this case. So negative 6 is in the middle. If I plug negative 7 into this, I will get a negative result. If I plug negative 5 into this, let's see, negative 5 times 6 plus 30, I will get a positive result, or plus 36. I'll get a positive result. Okay. So let's remind ourselves what we were looking for. We want concave up. So we want the positive portion of this. So we're concave up, f is concave up on -6 to infinity. Okay. Now we have to think about where they overlap. Okay. So notice if I wrote these two sign charts, so my first derivative and my second derivative on top of each other, -6 would be somewhere in this yellow region. 0 would be somewhere over here, right? So 0 might be here. So they would overlap in this region. Oh, and that's unfortunate that that makes it red. So there's our overlap. So the region we're interested in is from -6 to 0. So f is both, so this is our conclusion here, f is both decreasing and concave up on -6 to 0.